Welcome back to the car. I know it's been a little while. Life's been really busy. I'm having to work a fair amount these days. Got a whole bunch of projects going on at work. Unfortunately, none of which I can talk about. Learning a lot about, I can say in general, I'm learning a lot about power systems. Specifically computer-controlled power systems. And a lot of control theory. I can do the low-level programming, give me a math equation and a timing requirement, and we make it happen. But actually learning the mathematics behind the closed-loop control is pretty interesting and not something I've really had to know before. I just left my house. I'm on my road going out. I'm about 3 miles north of the Baltimore Beltway, and 195 miles of charge. See, it's one of these things. When I pulled out of my driveway, it said 198. I've only gone a quarter mile and it says 195. So the battery management system, you could use the mileage if you want to, but as soon as you start, it changes what percentage it thinks is in the battery, because as soon as you start loading the battery down, the voltage drops slightly, just very slightly. So the battery state of charge is really calculated using the no-load voltage on a lithium-ion battery. But I'm not in the no-load condition because I'm driving, so you have a loaded condition. One of the things I know about power systems is I've learned a lot about charging and discharging of lithium-ion batteries over the last 20 years, because that's primarily what's used in spacecraft these days. It used to be nickel-cadmium, and they were a lot more persnickety to manage the charge control on. Lithium ions, quite honestly, a whole lot easier. And they can deal with lower depth of discharge, and they don't have memory, electrical cell memory and stuff like that. So anyhow, it's the closed loop control stuff is really interesting, because you want it to predict what your target is and when you're going to reach it and what's the most efficient way to reach it. You want to reach it fairly quickly being whatever's in the requirements, but you don't want to go, like, if your electronics are rising really quickly and you're turning stuff up really fast, you don't want to go up too fast because you don't want to overshoot your target. So, if you want to be at 30 volts and you're at 27 volts, well, that's not too hard to reach. But if you're at, 5 volts and you have to turn up the electronics so that you're hitting 30 volts, then you got a long way to go. And so the math tries to raise that control level really quickly. If you go too fast, then you'll overshoot it, and then come back down, and you'll undershoot it, and it'll ring. It'll go over, under, over, under, over, under. What you really want it to do is rise to that, just below that 30 volt level. If you're coming up from the bottom, from 5, you want it to hit 29 and a half really quickly, and then kind of converge up to that target level. Well, that's what your charger does on the lithium-ion car and on lithium-ion batteries, and Tesla in particular. And you see that if you're out on the highway, for instance, you stop at a supercharger and you're at 20%, and you plug the car in, you're going to get the full power of the supercharger. But it's really important that you don't overcharge a lithium-ion battery, because if you do, they tend to, A, they'll degrade, or B, they can catch on fire. You overcharge them too hard. So you try not to overcharge them, because you don't want to degrade the battery life. And so your charging system is trying to be very conservative about that. So it'll when you start reaching the top of the charge, above 80% in particular, the charging system will start ramping down, because it wants to allow all the lithium-ion cells, of which there are thousands in a electric car, it'll start ramping that down to make sure that no one cell gets overcharged. And they'll kind of even out if you're not pumping them hard. They'll kind of, the ones with the highest voltage will take the least power. And so the battery management system, and in this case the charge subsystem in particular, will ramp down how much their power they're putting into the system so that everything equalizes out. And you see that if you ever try and use a supercharger to charge all the way to 100%, you just get a trickle charge above 90. It'll take you forever to get from 90 to 100. It'll take you as long to get from 20 to 80 as it can to get from 90 to 100. So I see those kinds of comments on forums and stuff, and just know that, you know, that's what the battery management system is doing. It has to taper off so that it doesn't overcharge the batteries. And we do the exact same thing in every control system that you'll see. There's a pretty nifty math equation that uses 3 elements of mathematics. A proportional control that's basically, well, if I'm really far away, that proportional control is going to be really high. An integral portion that's basically the slope of the line, and a derivative portion which is the change in the slope of the line. And I'm just seeing this BMW right here in front of me, and I'm distracted. Squirrel. His license plate says for wasabi. That's pretty funny. He's alto for wasabi. Anyway, and so this proportional integral derivative, PID, control is what's used mostly in the mathematics of closed-loop control systems. And implementing the math to do that is something I've done a couple of times, but figuring out how much of each of those elements you contribute to the equation is the trick. And those are called the K constants. So you have a multiplier, basically, which could be a very small or a very large number, that contributes to each of those generally, and sometimes they're negative. And figuring out those constants is the real trick of systems theory, and not something I really know how to do, but I'm learning. So we've got a great engineer, young engineer at our site named Matt, and Matt's doing fantastic work, working that up and doing simulations and stuff. So, all right, I got to get off because, yes, I'm driving my car and I'm going to work, and I have a conference call. It's 8:29, and I have a conference call at 8:30. So see you guys. Bye.